Hello students, welcome to this video. So in today's video, we are going to start the very first chapter of class 9, that is number systems. So in this video, today we are going to see the introduction part of numbers system. Okay, so let us start the introduction. So what I am doing is I'm drawing a number line. Dear students, please pay attention on this introduction video as this is going to be very important for you. Okay, so I'm drawing a number line and it starts with 0 and it has positive numbers towards the right side. It has positive numbers towards the right side and also it has negative numbers towards the left side. It has negative numbers towards the left side. Now in this introduction part we are going to see some numbers. Okay, so the very first terminology is natural numbers. The very first terminology is natural numbers. Natural numbers are also denoted by capital N. Natural numbers are also denoted by capital N. Now, which are natural numbers? So the numbers starts with 1, 2, 3, 4, 5 and so on up till infinity. That means all positive numbers starting with 0, all positive numbers starting with 0 are called natural numbers, now if we add if we add 0, if we add the number 0, if we add number 0, it comes whole numbers. It comes whole numbers. Whole numbers are denoted by capital W. Whole numbers are denoted by capital W. So what is whole numbers? All natural numbers plus 0. All natural numbers plus 0. So it will have 0. It will start from 0. Then 1, 2, 3, 4, 5 and so on. So what is the difference between natural number and whole numbers? So natural number starts with 1 and then it goes to all the positive numbers, whereas whole numbers starts with 0. Now in whole numbers, if we add some negative numbers in whole number, let us say if we want to add some negative numbers say -3, -2, -1, then it becomes integers. It becomes integers. Now, what are integers? Integers are denoted by Z. Integers are denoted by Z. So, integers have all the whole numbers plus it will have negative numbers. So, it will have -3, it will have -2, it will have -1, then 0, then 1, 2, 3, 4 and so on up till positive and it will go so on up till negative. Okay, so far we have done these three terminologies. Natural number starts with 1, 2, 3, 4, 5. If you add whole number, if you add 0, then we will get whole numbers. So whole number starts with 0. And if you add negative numbers, then we will get integers. So here on this number line sorry, so on this number line, if we want to represent these three numbers, how we can get it? So from 1 to infinite we will get natural numbers. from 0 to infinite, we will get whole numbers. And if we take negative, that means this entire number line, we will get integers, that is z. That is z. Okay, so I hope you understand these three terminologies. Now, the most important terminology that is going to help in this chapter, that is rational numbers. What are rational numbers? What are rational numbers? Rational numbers are denoted by capital Q. Now, which number we can say that a number is a rational number? So we can say that a number is a rational number if 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 it if that particular number is in P upon Q form. If that particular number is in P upon Q form. Now, what is P and what is Q? So where P and Q are integers, where P and Q are integers. That means P and Q can be any number from these integers. Integers means 0, positive and negative. And there is one more condition, is the denominator Q should not be equal to 0. Denominator means it is Q. P is called numerator and Q is called denominator. So the denominator Q should not be equal to 0. So any number that satisfies this condition, which condition? That it should be in P by Q form and the denominator Q should not be equal to 0. If any number satisfies this condition, then we can say that that number is a rational number. Now let us see some examples of that. Okay, let us see some examples of rational numbers. Okay, let us say 2. Let us say number 2. Can we say 2 is a rational number? Yes. How? Let us first simplify it in P upon Q form. So if we write 2 in P upon Q form, it comes out to be 2 upon 1. It is satisfying this condition. Yes. The denominator Q is not equal to 0. Yes, it is not 0. That means we can say that 2 is a rational number. Now, let us take one more example. Minus 3 upon 2. Is minus 3 upon 2 a rational number? Let us again check. It is in P by Q form? Yes, it is in P by Q form. Does the denominator is equals to 0? No, it is not equals to 0. That means minus 3 upon 2 is also a rational number. Let us take 0. Is 0 a rational number? Is 0 a rational number? Let us write 0 in P upon Q form. If we write 0 in P upon Q form, then it will become 0 upon 1. Okay, now here, though numerator is 0, but the condition is the denominator Q should not be equal to 0. So yes, the denominator is not equal to 0. That means 0 is also a rational number. Let us see one more example. 5 upon 2. Is 5 upon 2 a rational number? Yes, 5 upon 2 is also a rational number because it is satisfying our condition that it should be in P upon Q form. That means 2, minus 3 upon 2, 0, 5 upon 2 are all the examples of rational numbers. And the last terminology is irrational numbers. The last terminology is irrational numbers. Now, what are irrational numbers? The numbers which are not rational numbers. The numbers which are not rational numbers are called irrational numbers. Now, what are the examples of irrational numbers? So the example of irrational numbers are under root 2. Under root 2. One more example of irrational number is under root 3. One more example is under root 5. Okay, so root 2, root 3, root 5, and one more is pi. We know pi, the value of pi is 1.73. Okay, so pi is also a rational number. Now here you might be wondering, I wrote root 2, I wrote root 3, but I didn't wrote root 4. So is root 4 an irrational? No, root 4 is a rational number. Why? Because if you simplify root 4, then 4 is a perfect square. So the answer of root 4 is 2. Basically it is plus or minus 2. Okay, but even if you consider plus 2, then also it is a rational number, and even if you take minus 2, then that is also a rational number. That is why from here what conclusion we got is, okay, it is not that all the under root terms are irrational. Only root 2, root 3, root 5, root 6, root 7 all are irrational numbers. Okay, so hopefully you have got all these terminologies. Now again, the most important part is, let us start again from the beginning. Natural numbers. Now what we can say that all natural numbers are whole numbers. Can we say that all natural numbers are whole numbers? Yes, because natural number contains 1, 2, 3, 4, 5, and whole numbers also contain all the natural numbers. Therefore we can say that every natural number is a whole number. Now, again, can we say every whole number is an integer? Yes, we can say that every whole number is an integer. Again, can we say that all integers are rational numbers? Yes, we can say that all integers are rational numbers. So if we go from top to the bottom, if we go from top to the bottom, it satisfies all our condition. What condition is? All the natural numbers are whole numbers, all the whole numbers are integers, and all the integers are rational numbers. Whereas if you go from bottom to top, that means, can we say all rational numbers are integers? No, we cannot say, because rational, okay, all rational numbers are integers. No, because minus 3 upon 2 is a rational number, but it is not an integer. Again, the same thing. Can we say that all integers are whole numbers? We cannot say that all or every integer is a whole number, because integer contains negative numbers also, whereas the whole number does not have negative numbers. Again, can we say every whole number is a natural number? No, we cannot say, because whole number contains 0, whereas natural number starts with 1. So from top to bottom is correct. But if you go from bottom to top, that is wrong. That is wrong. Okay. So I hope you have understand this point also, because this is going to be very important for true or false, that is going to come in the very next video. So that's all for the introduction part. In the next video we are going to start exercise 1, and then step by step we will complete the entire chapter and we will complete the entire syllabus. So if you have liked this video, if you have liked this video, please like the video, and also you can subscribe to our channel, and you can share this video to your friends and in your class groups. So thank you and have a good day.